In this episode of Quack&Code, we'll talk about DuckDB and geospatial application. And for this one, I have a special guest. He is one of the main contributors of the DuckDB Spatial extension, Max Gabrielsson, working at DuckDB Labs. He's going to talk to us about his background and his story towards working at DuckDB, and also share what are the common use cases we've seen of people using DuckDB for geospatial application. He's going to tease us with really interesting features that you don't want to miss. That's going to be released pretty soon. And we're also going to dive on a practical demo from 0 to 1 using DuckDB and the spatial extension. Links are in the description for any chapter and the notebook demo, so feel free to jump and enjoy the talk. And so you're from DuckDB Labs. I get that question. I'm curious if you get that question. Yes. Exactly. I don't have my modern shirts. Do you have a DuckDB shirt? But yeah, can you tell us first what is DuckDB Labs? Compared to Mother Duck, because people get the confusion. We're forward.
Sure. So DuckDB Labs is a company founded by the main DuckDB creators, I guess, and the core contributors. And we kind of spun out of the CWI Research Institute here in the Netherlands to basically be able to support development around DuckDB through industry, basically. So even though DuckDB is free and open source, we provide consulting services and support contracts, basically, for people or companies that run DuckDB as part of their larger system and wants to ensure that development continues in the future, more or less. And of course, Mother Duck is perhaps like one of those companies that are building something on top of DuckDB, but we are, otherwise separate in that sense.
So Max, tell us about you and specifically with your background about spatial data and how the extension was born. That's in the signal.
Yeah, sure. So this is actually kind of a long story, but I'll try to make it short.
Go ahead. We have time. If it's too long, I'll just put you out.
No, but so okay. It all started with me actually. I was studying computer science, or I studied computer science, and I was on my second year of my master's, where I felt like I wanted to kind of take a break and work for a bit and just get out of university. So I joined this small kind of e-health startup, and the fun thing about joining one of these small startups with as a student in that sense is that you get very quickly a lot of responsibility, right? There's no company structure really. You are one of the 3 people that know how to program, so you get to wear every hat in that sense. But of course, this was a very ambitious product we had, and we had a lot of issues at the time managing our data. We had this kind of IoT system set up, so we were ingesting a lot of time series data constantly, and at the time it felt like there are solutions to these sort of problems. You could set up a Kafka cluster or a distributed timescale database or whatever, but all of these were super complicated, and we had no people, no money, no skills really, and there was nothing that worked for our scale in that sense. We resorted to doing the classical stuff, writing Python Panda scripts and bash scripts and whatever, but we were just in the middle ground where that no longer works, but we don't need or we can't afford to pay Databricks a ton of money at the time. So I was shopping around a bunch for databases, I guess. I'm looking that surely there must be something that can solve this, which is how I came across DuckDB. but we didn't actually end up using DuckDB at the time, and I left shortly after. But DuckDB was still kind of stuck in my mind as this genius thing where, yeah, these guys have solved this problem, right? Like they fill this hole. And so I was like following a lot of the development around DuckDB on GitHub, just casually browsing around the issue, seeing how things were progressing. And there was these people talking about adding geospatial support. And it just so happened that I had a bit of a background working with geospatial data in another kind of side project I had. So me and this my friends from school, we during one of these summers in university, none of us had managed to get an internship. So we felt like, okay, we need to do something useful still with this time. We need to build like a side project or put something on our CV, right? So we built this. We had this idea of selling posters of maps online. It's a bit embarrassing now to talk about it, maybe, I think, because it's not a very original idea. It's a very like typical, drop shipping, tech bro, get quick reach scheme type of stuff. But I don't know. We thought it was like something that was kind of doable and would be fun. And even if we sold one painting, that was still, a good return on investment, so to speak. So that turned out to be incredibly hard, or incredibly like much harder than we anticipated it to be. Mostly because I think I really wanted us to have kind of an original tech solution. If we weren't going to have an original idea, I wanted to have an original stack in that sense. But that whole like project took me through a lot of just the whole like tour around geospatial data management, particularly because we really wanted to a core feature of this poster business was that you would be able to select any place on the earth and get a poster of it. Yeah, which meant that we had to always work on this kind of global scale data sets, right? Like with OpenStreetMap, Planet Dump, like learning how to process that efficiently, and also like pouring a ton of downloading terabytes and terabytes of satellite like height map data to produce contour lines that also look good. Like these are still kind of problems that I don't think I ever have managed to solve completely, but still it was a great speed run to learning geospatial data management. But a core thing that I think I really, of course, I got a lot of skills out of it, but I also got a lot of, I think, frustration in a sense that things are much harder than they need to be, or things don't scale properly, or they don't work well for planetary scale data. They had the same kind of problem that I was running into in at work, basically, where there's nothing that like solves the middle ground, 100 gigabytes problem. So when there was talk about geospatial support for DuckDB, I felt like, okay, if you guys want to add geospatial support, here's all the things that I would think about if I were you, basically. So I think I wrote this. It's probably still there, like this kind of unhinged comment on the GitHub thread, and then I mentioned like maybe if I go back to university, I can maybe do my master's thesis on this. And Hannes saw that, and he was like, Hannes, one of the core founders of DuckDB. He saw that, and he was like, "Yep, sounds good. Email us." So I sent him another crazy email with like all my ideas for DuckDB Spatial, and then he was like, we have like an internship program. Does that sound cool? Yeah, sure. Do you want to come to Amsterdam? Yeah, sure. And then, one thing led to another, and I guess now I'm still here.
That's cool. And so you're like rolling up. You've been in internship at DuckDB Labs, starting as geospatial extension. Now you're doing other things also.
Yeah,
is that true? It's like your core responsibility. Like spatial extension is still your baby, if I understood correctly, and you have other stuff around. Can you maybe elaborate on that?
Yeah, sure. I mean, I think it's I've been trying very hard to not, because I already have like spatial as kind of my corner. I've been trying very hard to not necessarily fall into one I don't know, not whole, but like one part of the code base otherwise. Like I try to do a lot of different things and always dive into learning something new. DuckDB is pretty young database, but it's still a pretty substantial code base with like very different different modules and stuff. So I'm trying to do a little bit of everything. Mostly, I think I've done a lot of stuff on the kind of execution layer side. Like I've added support for new types, like the union data type was one of the like first things I did, and then I also added this array or fixed size list data type recently. I'm hoping to do more of that sort of like execution and like operator implementation in the future.
Yeah, it's really interesting because like whatever is not like crucial for DuckDB core, it's going into an extension, right? But some parts, sometimes you realize, I feel like, oh, this actually shouldn't be part of the extension. This should be put into the core. Is that correct? So I feel like that's
and a lot of times you want to do something in an extension, but it's not possible in that sense. Like those hooks aren't available in core DuckDB. Like for example, this whole thing with like indexes now, we're slowly getting support for custom index types through extensions, but that took a lot of work to make that all work with as an extension, particularly because DuckDB itself, like anything that touches the storage basically is kind of then you have all these complications of like what happens if you load a database without the extension loaded, or have another different version of the extension, and like all that stuff gets very quickly very, very difficult.
Yeah. And so we have already a couple of comments in the chat. Please let us know that someone that I've been trying to go for DB to store group. It seems that lately GeoPark and Tal DB have been mentioned by GDAL, and Tal also had a geospatial module. And how do they compare for the future? Is Raster and geometry in the pipeline? Maybe you can comment on this one. So is Raster and geometry?
I have personally been not very interested in adding Raster support for DuckDB because I think Raster support in databases in general is really hard unless you have like a sort of kind of domain specific like multi-dimensional array database. I know like TileDB is really going hard on that sort of stuff. Like my own experience from trying to use rasters in PostGIS hasn't been great compared to like just running a bash script in GDAL or using a Python library for it. So I'm not sure that it's actually like, I'm not convinced that it's super it's a good idea, maybe, or maybe it is. Like maybe there is a way to make it happen.
And what kind of other stuff are you see popping up? Because it's not the first time you've been asked this question. I saw someone said Raster is in relational database is a fool's errand. Yeah,
right. That's kind of the idea I got. But the thing is, we actually got somebody that produced a pull or made a pull request that adds support for rasters through the libraries and stuff that DuckDB Spatial already supports. And I think that's a really impressive pull request. It's very large. It's by far the most like substantial and involved, third-party contribution I've received to Spatial. So I'm really thankful for that. And I haven't had the time to really dive into it and like think about it, like what the effect of merging this would be on maintenance and future work and all that stuff. But I do want to get back to that at some point and actually have a look if we can merge it, because I don't want to just throw away that work. Like if it's useful for somebody and it's not too much maintenance, then I think it's worthwhile. So if anybody's watching this and interested in contributing, then or have any questions, like of course you can throw up a pull request, but you can also, if you have any questions,
which place would you send people over there?
For one, there's a Spatial channel on the DuckDB Discord, where I think like is maybe the most active kind of chat, I guess. Otherwise, you can always make a GitHub discussion or open an issue or something, and I monitor that pretty closely.
So someone said that he's been working with DB Geospatial and in tandem with PostGIS, right? So I would like to, that tell us the story around what is inspiring geospatial extension, and how do you compare yourself today, with PostGIS and like in the future, basically.
Yeah, so I mean, I think I've been pretty open with the fact that the DuckDB Spatial extension is very much inspired by PostGIS, mostly because I have spent so much time myself with PostGIS, and I think PostGIS is probably, at least like in the open source scene, the most feature complete, geospatial SQL implementation, if that makes sense. So if you think about like adding geospatial support through a database, there is a lot of different directions you can go, and a lot of like the geospatial field itself is pretty large. So I think having like PostGIS as kind of a blueprint in that sense, or like a formula of like, these are the functions that people expect, these are the functions that people use, has been very, very helpful. And also because like I think it's very ties very well nicely together with like other open source libraries, or the geospatial ecosystem in that sense. And like PostGIS has hundreds of functions and features implemented. We are not really close yet, I think. But I don't know. I think we're. I mean, PostGIS has been around for like 20 years or something more, I think. So
yeah, we are not talking about the same latency, I would say.
Yeah, exactly. We'll see. I think we're gonna continue to mostly follow in their footsteps, at least for the common functions and stuff. I think we're probably gonna start to diverge a little bit, maybe when it comes to like projection handling, and maybe what do you call it? Geodesic computations, or like spherical computations. I have some ideas for how we should support that or enhance that in DuckDB Spatial, which might be different from the PostGIS approach.
Can you share a bit, like, what's your kind of guideline in terms of vision around the spatial extension and user experience for you? A couple of idea or this design decision you made explicitly for that.
Yeah, good question. I don't know. I think there's been like a couple of things, but I think one thing that like DuckDB itself does pretty good is this like working with nested data types, basically, right? Like DuckDB has these list data types, or like struct data types, and I think there are a lot of like geospatial functions that, or also like going back a bit to this geometry type itself, right? Like one of the first things I did was to not just support this geometry type, but also add these vectorized data types, right? So in DuckDB you can create like there is this point 2D data type that is internally represented completely different from the standard geometry type, but it's like typed in that sense, right? And all the functions that are implemented for it are implemented just for that, which I think could, make the user experience a little nicer, especially if you're not super familiar with like the simple features geometry model. Like if you don't come from a GIS background in that sense, like you just want to store some points and compute some polygons. All right, let me create a point column. Let me create a polygon column. And I think also like some of the functions I've implemented deviate a little bit from like how they work in PostGIS by returning or taking these nested types instead, right? Like I think we have, for example, there's this stCollect function, which I think in PostGIS is an aggregate function. Like you call it over multiple values in a column, and it combines them all into a geometry column. But in DuckDB, you can also pass it a list data type containing multiple geometries instead, and combine it kind of horizontally in that sense. So there's like some small things like that that I think make the UX maybe a little better. But honestly, user experience in that sense hasn't been like the main priority for me yet, and I think that's something that I really want to focus on more. I have some ideas on something that I think is going to be in the next spatial release. For example, so all of these geospatial functions are by convention kind of prefixed by this st underscore, right? You do like st underscore point, st underscore contains, whatever. Now, DuckDB has this kind of nice underused feature, I think, called function chaining, where you can, instead of having to wrap all your functions in a bunch of parentheses, you can also, given a column or a data type, you can do dot the function name, right?
Yeah.
And then it will like pass the thing you're dotting on as the first argument to that function. So I think this is super useful for a lot of this geospatial processing, because we tend to use a lot of these nesting functions to split points and extract centroids and whatever.
And nesting them is start to get hard to read, right? If you start to nesting.
Yeah, exactly. But it's still a little awkward maybe because everything has this st underscore, right? So I think in the next release I'm gonna add a bunch of aliases basically, or macros for common geospatial operations. So instead of saying, st underscore contains polygon point, you do just polygon dot contains points, and then voila, it's like reading Python again. So yeah, there's some things I think I've done, like also, yeah, like when you print a geometry in the CLI, for example, you get the well-known text output immediately instead of like the binary representation or something that in PostGIS. I think like there are definitely some small stuff where I've been like, yeah, this just makes more sense in that sense. But
what kind of common use case you see with spatial extension?
Honestly, a very common thing that I see people use it for is, or I guess like a surprisingly common thing I see people use it for is mostly as a kind of like data like conversion utility, or like ETL style workloads, right?
Yeah.
Which is, I think, a little surprising because DuckDB Spatial itself really just calls into GDAL. But I guess for a lot of people, it's if you're not like super computer savvy, it's a little scary maybe to I don't know, write a bash command that invokes OGR to OGR with a bunch of parameters and stuff, compared to using like a SQL interface to it.
Yeah.
So that's, I think, a very common thing, that people just have a GeoJSON, they want to flip it and convert it into something else, right? I think also as like a very huge thing has been this GeoParquet support, which is also kind of ironic because DuckDB itself, or DuckDB Spatial, hasn't really supported GeoParquet like properly, right? But just because DuckDB itself is one of the quickest way to just convert and read a Parquet file, that's been like in the GeoParquet kind of adoption space, it's been really huge. Like for a long time, I think pulling data from this Overture map data set that is becoming very or making a lot of noise. Like the easiest way was just to download DuckDB and write a SQL query to read it. So I think that's like that sort of workload is where DuckDB Spatial has really shined.
Yeah, so transforming basically some data set into specific spatial formats, I think one picture I want to show the people is actually this one. So this is one of from your talk, by the way. I'll share directly with the people on the chat. Can you explain a bit this picture?
Yeah, so yeah, this was kind of a joke, but like yeah, the I think so. This picture is from a segment where I'm talking about just the fact that DuckDB gives you actually a storage backend, right? Like DuckDB isn't just a data frame or a query engine; it's actually a database. And why is that important? Well, somehow we have ended up in this state where people think the database, or like data analysts at least, think that, or tend to think that databases are too complicated and too annoying to work with, or too hard to set up. So instead of using a database to actually store your data or to manage your data, we like have this kind of end up with this, zoo of random data files and scripts and whatever, and it's all just a mess, and you end up like you lose all the things that a database normally gives you, right? You lose transactions, you lose backups, you lose isolation, like durability, all of this kind of, even just having like the relational model, right, where you can store things in a normalized fashion and then join different data sets without having to duplicate a bunch of data all around. That's like super useful, and you lose all that. You give that all up by refusing to use a database, and I think that's it's a bit ironic, maybe. So
yeah, no, but some people say that slide is great, and I think it is an underrated feature from DuckDB. So DuckDB has its own, storage format, and I think specifically with geodata, when you start to have different kind of file that you pull here and there, it's going to be just much cleaner to have, everything. And this is coming back to the main use case you mentioning with like ETL, and pre-processing. You basically want to have, a tool to pre-process that, and at the end of that, have those all cleanup data set instead of export clean _1.csv.
Yeah.
And basically, and also don't use CSV for like pre-processing. At least put it in Patch. Yeah. But yeah, so I think that's a really great slide. That's making the point. I think we're gonna see much more usage of the storage file format. I'm curious if people in the audience, if you use DuckDB with mostly CSV or Parquet, or you are still, or do you leverage the file format of DuckDB? It's a one file format that includes all tables. I'm curious. I think because now we are past 1.0, so there is no breaking change. I think people are gonna be a bit more keen to dive into that. What do you think?
Yeah, I think I also see the the comment in the chat. Will spatial extension support some kind of index like an artery? And I think that's also perhaps one of the kind of driving factors why you maybe don't want to store your geospatial data in DuckDB right now, because there is no spatial indexing. So I think I've seen a lot of people like export their tables into flat geobuffs or I think even shapefiles, like something that has a spatial index. But I am, happy to tease maybe that is changing soon. I am finishing up the last touches on adding a spatial index, an R3 to DuckDB Spatial, which I think then is gonna also increase the kind of adoption of the DuckDB Spatial like file format itself as a container for geodata. So really, really excited to talk about that. But maybe we can talk about that a bit later. We'll see.
Yeah. I mean, we can go now. I mean, I think it's really good transition. Speaking of like the DuckDB storage format, and it's true. So as what's the added value today? You support ACID transaction, right? But now DuckDB has also a lot of support for table format that has, limited support still. Delta Lake, Iceberg. So you could say, yeah, but I'm still working with those file formats. Then there is GeoParquet. Maybe you can give us a bit before talking about this index. What's the current state of GeoParquet?
So, GeoParquet is this kind of extension format, I guess, on top of Parquet. It's basically like a set of conventions on how to store geographic data in Parquet files, also with like some standardized metadata. And I think a cool thing about GeoParquet is that because it's always this like extension format on top of normal Parquet. Like you don't need necessarily a specialized like Parquet or GeoParquet implementation or scanner or whatever in your system. You can, if you support normal Parquet, you can jump through some hoops and also support GeoParquet. And so that has been like how GeoParquet has worked in DuckDB Spatial so far. Like DuckDB Spatial won't necessarily convert or write all the metadata as GeoParquet mandates it to, but you can do that yourself manually, basically. But that is also changing in the next spatial release. I actually got it merged a couple of weeks ago, where now if you use DuckDB with the Parquet extension and you have the spatial extension installed, and we realize that you're trying to write, a table with this geometry column, we will then convert it into like the internal Parquet encoding, and also collect and write the kind of metadata and like statistics that's required by GeoParquet. And also when you read then a GeoParquet back, you also get like the geometry column immediately back. You don't have to decode it from WKB yourself. But yeah, so far it only supports the GeoParquet 1.0 spec. There's this 1.1 spec that also was released that supports some other like geometry encodings. We will probably support that too at some point. I just haven't gotten around to it. But yeah, like the kind of core basics will be there. A lot of the kind of friction of using GeoParquet through DuckDB will disappear. So yeah.
So GeoParquet is there, and so now coming back to the index and the DuckDB file format. So people can still leverage those external file format, but then there is definitely an added value for the DuckDB storage, because you get ACID. It's a one file format to manage all your tables, and also for MotherDuck. If you work with the cloud, it's really easy to move from one local database to a cloud database. We store your cloud DuckDB database for you. And so now you are investing a bit more into that with the index. What kind of performance or like efficiency you're looking forward over there with this feature?
It is. I think it's gonna be like a game changer for the spatial extension. It's like the sort of like you get like 2 orders of magnitude speed up basically when filtering on geometries. And I think in particular it's like how I implement it now. I still don't really use it for if you do like a spatial join, which is also like a super cool thing to do later. But just like filtering, if you just say you have a huge table of geometries and you want to give me just everything in this little box. How DuckDB has to do now is it doesn't matter, like even if DuckDB itself is fast or multi-thread or whatever, we still have to pull the entire table. We still have to do a sequential scan through everything. But with this index, that's no longer the case. Then we traverse this R tree, but we can figure out exactly which row IDs we need to pull, and we only fetch those from disk. So this does make a huge difference, particularly if you actually use like the DuckDB file format and store geometries in it. It makes like so many use cases now become like actually feasible in that sense, because with this index. So it's going to be really, really awesome.
And so that would be for when we should be. Can you share or not? It's okay if you don't want to share a timeline specifically of the release, but a roughly timeline?
I think it's for sure gonna be in the next DuckDB release, which is scheduled for early September, I think.
Okay.
But I might also merge like the basic support in Spatial in the next couple of weeks or something. Like it's really not a lot left on it. It's just some polishing, some testing.
Cool.
But it's really gonna be awesome.
That's great to hear. So to wrap up, if you've been using external file, GeoJSON, GeoParquet, and what server, now you can leverage a bit more the DuckDB file format and benefits from the index, which is going to be drastically speed up everything. So let's start into the coding. So we have a small collab for you, and we're going to walk you through. But you're going to see that it's a really small one because it's super easy to get you started with DuckDB. So I'm sharing the link on YouTube, and I'm sharing the link for our people on LinkedIn. There you go. So you should be able to access this one. And let me share my screen now with this. Let's go. There you go. So it's a simple collab. You can't, there is no MotherDuck involved. There is actually another notebook with MotherDuck. We're going to talk maybe just a small plug after it. So maybe you can talk if you've been a bit hearing or not about longboards. You've met the author you mentioned just before going live?
Yeah, exactly. No, I met Kyle at GeoPython, the conference where I was giving this talk in DuckDB Spatial. He also did a talk on longboard there, which I'm sure is in the archives somewhere. But yeah, longboard is this, maybe you wanna you have.
No, go ahead.
The explanation ready. Okay. So longboard is this visualization library for the web that is. Or no, wait, it actually isn't, right? It runs in a Jupyter notebook. That's the whole thing, right?
Yeah.
Anyway, it's this visualization library, and it's makes use of this kind of geo arrow, like columnar geometry encoding, combined with WebGL, I think, or the GPU basically to visualize or to make these really, really large geometry visualizations, like heat maps with hundreds of thousands of points or all that stuff. And it can do that very efficiently because it has this very efficient data transfer format internally to move things in and out of the GPU. But he also added support for DuckDB, which I think is pretty awesome. So you can very quickly from a DuckDB result set immediately plot that out through longboard.
And so this is where I wanted to do, because so we have GeoPandas, which is kind of I feel a standard, at least in the Python geo world, but it can be heavy. And I think here what's fun is it is database library, and it has integration directly with DuckDB. So I'm just going to install it. It's done. And then we have basically this block. I'm instantiate the connection. I'm installing and load the extension, but sometimes I do not need to do that, and sometimes I do. Maybe you can comment on that. Why? And what would be your recommendation?
So when the thing is, if you don't have the extension installed already, you need to run install, and basically DuckDB will then download the extension and put it in your DuckDB home directory on your disk basically. And then you don't in theory need to install it again. If you call install again, DuckDB will just realize that, oh, it's already here, I don't need to fetch it. But you do need to call load to then load extension into memory and make sure that all the functions are available. Usually. The fact is, this is kind of one of those like user-friendly things about DuckDB is that DuckDB itself has kind of a list of some like common known functions and file formats. And if it realizes that you're trying to call this function or open this, I don't know, FGB or shapefile or something, it knows that, hey, I don't have the spatial extension installed now, but I know that the spatial extension can provide this function or load these data formats. So I'm going to load it transparently instead, which is why you might have realized that sometimes you may not need to load the spatial extension itself. But if you want to be sure that everything works, then yeah, you can also just always load it. It doesn't matter.
Yeah. But so that's a great point, because basically here we're installing the extension. We do a query, you're going to come there. But as you see here, I'm querying directly a remote Parquet. So basically here there is two extensions. I'm not specifying that I'm reading a Parquet, right?
Yeah.
So there is a hook over there to say, hey, that, is trying to read Parquet. We're going to install what's needed for that. And same because it's over the net. So there is a HTTPFS extension. And it's funny because I have a lot of videos that have quite some view now on the Mother Duck channel, where I always install, I think it was on 0.7, 0.8, where I always had to install HTTPFS extension. I think I haven't done that for a really long time.
Yeah.
I don't see why we do that. So this is like the hook and, the automatic installation and loading that we were talking to. But the spatial extension is pretty large, right? And I think having all the function might be a bit tricky, because you might load this extension, accidentally. I don't know. But there is those, the point is, like, when you work with spatial work, you better install and load so that you're safe to go. But there is a lot of like extension where it's not really needed anymore, like HTTPS or PARI. I never done that. But so this is happening in the wood. Yeah.
Exactly. On some platforms, we also like bundle basically the extension already pre-installed in DuckDB. Like I think HBS is mostly on, most platforms it's already built in that sense. I think JSON Parquet is also built in some, but yeah.
Yeah. So now this is from directly a remote Parquet. So that's the beauty. I don't have to download it. I don't have to specify. I'm just, it's yellow trip data. So, New York taxi data set, famous data set. Basically, I'm doing a where condition where I just defining a box, basically a box boundary based on coordinates with a certain limit. And that's pretty much it, right? Do you have anything? Yeah, so that's the thing. Do you want to comment on this one?
Yeah, I guess it's the first spatial function we've seen. So SD points, it's pretty obvious, but it takes two coordinates and turns it into a geometry, a point geometry in this case.
So I'm going to run it. And while I'm running it, there was a comment, by the way, that someone has been playing with isValid function and loving it. So
awesome.
Can you tell us what the function is doing, actually?
So in this kind of geometry model that DuckDB supports and other databases also use, there are like some kind of invariants around geometries that we can assume will always be true. So for example, if you have like a polygon, right, that's defined as a sequence of coordinates as like the outer shape, but you can also have like holes inside of this polygon, which is then defined as another like sequence of coordinates. But then like one of the kind of rules is that the hole must always be within the outer ring. Mm-hmm. And that's like hard to maybe always guarantee in the code base. It's to check if that's always the case is it's a bit expensive. So we just say that, okay, if you have geometries where the hole is not inside the polygon, then that geometry is invalid and you can't expect your functions to produce correct results, basically. So then you have this function SD is valid, and I think also SD make valid, but I'm not sure if I actually managed to port that or not. But yeah, to check that these geometries actually hold, that there's no craziness going on here. Like, yeah.
Great. So here we've done, so it took, as you see here, 14 seconds. So pretty fast for 1 million rows. And here it's just a display of the data. We have our geometry points. And now basically we're ready to display it already. So that's it. And this is the library with Longboard. We just call from DuckDB the table we want to display. And it is a heat map. And so we're going to see it. So it's going to take a bit of time. And while it's doing it, I have another example here for you. I'm going to write actually a blog post about it because I found it very interesting. Data set is, have you heard of OpenCharge map?
I have not.
Yeah, so it's one of the largest open data set for EV charging spot. You even have picture, so you can see all around the world people, taking picture of how it looks like around, and so yeah. So I'm going to go there, but you see, so here it's in New York, and so I have my heat map here, which is display on the yellow traffic data for taxi. And the other, you have of course multiple ways to where you want to display it. Here, what I did basically for the geospatial is just filter on the box, which is to believe I filter on the box, but I don't see any filter here. So this is I think it's because I filter here actually. So in the open data set, it's pretty cool. They have an API, so the OpenCharge map is a really great data set, and you can query directly an export, and you can pass a bounding box. So here I pass a bounding box which is around Berlin, because this is where I'm based, and I want to see how much charging point for electric vehicles there is around. So this is really great because, again, no need to download the table. I can directly query from this remote data set with a bounding box. So I'm pushing the filter on the server side and then directly display it. So you see it took us 1 second, really fast. And now I'm just going to display this. And here you go. So this is all the charging EV around Berlin. Just zooming out so that you can see. And once I zoom in,
What is that? How many points is that?
I think it's around. So the export is around 15. I think less than 10,000. Yeah.
Okay. Oh.
Because you have, so the thing is, Berlin was it's still a lot because Berlin was of the first city to experiment with those sharing car with your, phone, because Volkswagen and Mercedes are, based in Germany, and they decided to test it out in Berlin a couple of years ago before scaling to other city. And a lot of them were investing into electric vehicle because it's just easier to manage, the pool and to charge it. And so that's why there was a huge investment. And then Tesla Gigafactory is basically right there. So one of the largest factory in the world. So that explains why there is so many. But anyway, fun data set. As you see, it was super fast to go from 0 to 1. We just installed the extension, convert to ST point. There is multiple function. I'm going to send people over the documentation around spatial extension. So here you have a lot of...
There's even more now, actually, but I need to update the docs.
Sorry?
Yeah. There's even more functions, actually. I just haven't updated the docs. But yeah.
So there is even more than that, but you can go and play around for those extensions. You have the collab, but it was really easy to just get data from remote. I didn't download anything locally, and just using Longboard, which has a direct integration to display. So it's really great because you can. I think that's the biggest problem I had in the past with geodata is the iteration phase, right? How to display something that is, meaningful, and tune it, the display and so on. And I feel like maybe reprocess something before or join some data with other things. And I think that's the magic with DuckDB. What's next for you? We talked about the index, but anything else you're mostly excited before closing in?
Yeah, no, so I think the index is the big thing. With that, a lot of other things all of a sudden become possible. So, and we for a long while have had this request to add this ST as NVT, basically be able to convert a set of geometries into a vector tile that you can then feed into a mapping library or send over the wire to the web. That is like, if you have an index, that all of a sudden becomes like actually useful to be able to generate maps from DuckDB data. So that's definitely something that I want to have a look at. I also have some ideas for better projection handling. Right now, if you want to work with different projections, you need to kind of juggle around the SRID or CRS identifier yourself. But I have some ideas how to make that kind of nicer to work with, and also maybe like type safe even, so you can't accidentally mix or mix up the wrong coordinate order or stuff like that. So there are definitely a lot of things on the way in that sense. But I think the big thing is the index that is going to change a lot.
So that was great to have you around here. Please check out the Spatial extension if you want to contribute, if you want to use the function. You have the Google Colab. We'll put it in the description on the video if you want. If you're watching this video from YouTube later, just play around and you're going to see how easy it is to get with geodata, which wasn't the case, a couple of years back. So we really invite you to do. And if you find like an easy way, I'm always challenging and open to ideas. Please give us the stack. If there is a competitor doing better, or, would it be an open source or commercialized? I'm curious because I haven't found it, right? So it's not that I'm biased. It's just I haven't found it yet. The Quack&Code episodes are happening every other week. And so I'll see you in 2 weeks. And thanks again, Max.